All right, so we've got a differential equation, dy dx equals e to the x over y root 1 plus y squared. And so if we're looking at that, we should recognize right away that that's a separable differential equation because it's got one function in terms of x, e to the x, and it's got another function in terms of y, which is the 1 over y root 1 plus y squared. So we'll separate the variables, which means we're going to bring the y root 1 plus y squared to the left. So I'm going to multiply by that. So I will have y root 1 plus y squared dy is equal to, and then I'll bring the dx over here. So e to the x dx. So far good?
Yeah.
Okay. The right-hand side, when we integrate, so we're gonna integrate both sides, since that's what we always do with our differential equations. The right-hand side should be pretty straightforward. That should just be e to the x plus our constant. And there was no initial condition, right? This was just a general, finding the general solution.
Yeah, just general.
Okay. And so then the other side, though, is going to be a little bit more complicated because this one requires us to do a u substitution to integrate that. So we are going to let u equal 1 plus y squared, which makes du 2y dy. And that means I'm going to need to put an extra 2 in here, which means I'll put a 1/2 outside. Good with that?
Yeah.
Okay, so now we have 1/2 the integral of 2y dy gives us our du, and then root 1 plus y squared is a root u, or u to the 1/2 du. So now we can integrate. So that'll go up to become a u to the 3/2, and we'll divide by 3/2, which is multiplying by 2/3. And if we multiply that by the 1/2, it's 1/3. So we end up with 1/3 of u to the 3/2 equals e to the x plus c. And then we need to replace the u with 1 plus y squared. So we've got 1/3 1 plus y squared to the 3/2 equals e to the x plus c. And now we just solve for y. So the first thing is we're going to have to multiply everything by 3. So we're going to get 1 plus y squared to the 3/2 equals 3 e to the x plus 3 times that constant that we had. And then to clear out a 3/2, we'll raise to the 2/3 power, which is the same as squaring it and cube rooting it. So, or we can just write this 3e to the x plus 3c to the 2/3 power. That's also fine. We'll subtract 1 from that. And then we'll need to square root it. And when we square root it, since we're just looking for a general solution, we're going to put a plus or minus in front of it. Oops, I forgot to put my -1 there. We're going to put a plus or minus in front of that square root because we don't have an initial condition, and it could be the positive version or it could be the negative version, depending on if we gave an initial condition. If we had a negative y value or a positive y value, we'd pick the appropriate one. But since we don't have that initial condition, we'll just put the plus or minus. Does that make sense?
And so we need to, why do we need to leave the 3 in front of the c? Because wouldn't that just be a constant as well?
Yeah, I mean, technically, yes, it's just a constant. I leave it there just because if I don't, I'm saying that 3 times this original constant that I had, 3 times c, is then just equal to c, which is not true. It's just equal to some other constant. So if you wanted to, you could initially start off, since you knew you were going to have to multiply by 3, you could call this c sub 1, let's say. And then this would be c sub 1, and then this would be c sub 1, and then you could say 3c sub 1, and then if you wanted to just change that to a c, you could just somewhere in there notate like, oh, c or 3c sub 1 is equal to c, and then you just get rid of all the 3's throughout. But that's not necessary.
Thank you.
I just leave it as the 3c if you're doing a general solution, or a 7c, or a, whatever it happens to be. Does that make sense?
Yes, thank you.
So expect your quiz to have 1 or 2 general solutions and like 2 or 3 particular solution type problems. Okay, what was the other one I was asked about? 2D, I think. Yeah, 2D. Anybody want to tell me what 2D is there? I bet it's dy dx equals something.
4x cubed times tangent y with y equals pi over 2 and then x equals 1.
Okay. So dy dx is 4x cubed tangent y with y equal to x. Y is equal to pi over 2 with x equal to 1. So again, it's a function of x times a function of y. It's a separable differential equation. So this becomes dy over tangent y equals 4x cubed dx. And dy over tangent y, we don't really have an integral rule for that, but what's 1 over tangent y the same as?
Cotangent y.
Yep. So this can become cotangent y dy equals 4x cubed dx. And we did do an integral for cotangent y. We did it using a u substitution, right? We wrote cosine over sine and let u equal sine. And what was the integral of cotangent y?
Natural log of absolute value of sine y.
Exactly. Natural log absolute value sine y. And then on this side, that just becomes x to the 4th plus a constant. And so if you don't remember, if you didn't memorize that rule for the integral of cotangent, that's fine. Just know that you need to write it as cosine over sine. Let u equal sine, and then do your integration using the u substitution. Okay. So then from there, we'll plug in our values. So we got natural log absolute value sine pi over 2 should be equal to 1 to the 4th plus c. And the sine of pi over 2 is 1. So this is natural log 1 equals 1 plus c. Natural log of 1 is 0. So we get a constant of -1. Everybody agree with that?
Yeah.
Okay, so now we have natural log absolute value sine y is equal to x to the 4th minus 1. And we need to solve that for y, which is going to be a little bit of an issue. Not an issue per se, but it's going to require some work here. We're going to have to exponentiate, which will just give us absolute value sine y. It's e to the x to the 4th minus 1. And then we can clear off the absolute value and pick the appropriate plus or minus over here. So initially would give us sine y equals plus or minus e to the x to the 4th minus 1. And based on the value x equals 1 and the value y equals pi over 2, which one do I want, positive or the negative?
Positive.
Yeah, we want the positive one, right? Because if I had negative over here, that would mean that the sine of pi over 2 would have to be -1. So we're going to then say sine y equals just positive e to the x to the 4th minus 1. And then we'll do the inverse sine. So y equals the inverse sine of e to the x to the 4th minus 1. And so far, so good. Everybody okay with getting that as our solution? Hopefully. And
Yeah.
then after that, we'll need to find the interval on which it is valid. And so I'm going to give us a new page for that. We've got the inverse sine of e to the x to the 4th minus 1. All right, so first off, what's the domain of the inverse sine? What are the only values you can plug in to inverse sine?
-1 to 1.
-1 to 1. So we're going to say -1 is less than or equal to e to the x to the fourth minus 1 is less than or equal to 1. So right, whatever I plug in to inverse sine, which is e to the x to the fourth minus 1, has got to be between -1 and 1, and it's inclusive on there. Then we'll need to take the natural log of both sides. All right, so that's going to be a problem because the natural log of -1 doesn't exist, right? But when we take the natural log of the middle piece, we're just going to get x to the fourth minus 1. And what's the natural log here of 1?
0.
Yeah, should be 0. I'll just write natural log 1, which equals 0. And then on this side, we can sort of start to forget about this because we know that we're never going to get anything in here that is between -1 and 0, because then we won't be able to solve for x. So that can be ignored. So now we're looking at x to the fourth minus 1 is less than or equal to 0, which tells us that x to the fourth is less than or equal to 1. And that tells us that what? If x to the fourth is less than or equal to 1, that tells us that x must be less than or equal to 1, greater than or equal to -1. And so this is the only, there's no other discontinuities on here. This is just the values of our domain of our function. And so we will say that this is valid for -1 to 1, since there's no other discontinuities. That's just its domain. Good or no?
Good.
Anybody have any other questions on that or any other problems? So just in the interval for 2e, that was the one I think I said in class that you had to use a calculator for, and that you don't need to worry about that one. You're not going to need a calculator for any of the intervals on the quiz or even on the AP test. If you really want me to, I can work through it, but it's kind of a pain. So
just to clarify, in like the general solutions, do you, when it comes to a thing that's like e to the power c times e to the power something, do you always use a for e to the power c?
you don't have to replace it with another variable at all if you don't feel like it. It doesn't have to be a, it could be any variable you want it to be if you want to replace it though.
All right.
Justin, did you want me to go through and do the interval for that? Show you how to do it on the calculator or no? Anybody else? Any other questions? All right, I guess we'll start with today's lecture then. So today, the new thing that we're going to start talking about is how to find areas, specifically the area, not just the integral of something, given some function that you've got in the coordinate plane. Okay. So the first thing that you always want to do when you're looking for these areas is to graph whatever function you're looking for. So graph the function, make sure the function is continuous on the interval, and then look for any x values where your function might cross through the x-axis. If it just touches the x-axis and then bounces off of it, that's not a big deal. But if it crosses through the x-axis, that means you're going to have one portion that's above the x-axis and one portion that's below the x-axis. And so when you have that situation where it crosses through, you have to integrate each of the pieces, the piece that's above the x-axis and the piece that's below the x-axis separately, because any values that are below the x-axis come out to be negative, and any values that are above will come out to be positive. And so if you combine those together, it's going to cancel stuff out and make your area a little bit off. So like, for example, if I have a function like this, and I say find the area between here and here, you can't just integrate from A to B, because this area will be positive, and this area will be negative when you take the integral, or this value will be negative when you take the integral. And so part of the positive will cancel out with part of the negative. But what we want is the positive plus this turned into a positive, because we want the actual area of everything blocked between A and B and the x-axis and this function. So anything that you integrate below the x-axis, you have to take the negative of, and then just add your areas together. If you happen to have a discontinuity, then you just integrate up to that discontinuity, and then you do it a second time from the discontinuity to wherever you're finishing. Finding the area itself is fairly straightforward. The biggest thing you got to remember is look for those places where your function crosses through the x-axis, where your function has x-intercepts. Okay. Easy enough, good enough? Any questions on that?
Good so far.
All right, so we're going to start with a nice easy one. We want to find the area of the region bounded by the x-axis, x equals 2, x equals 5, and the function f of x equals x squared plus 1. So we start off with graphing it. What does f of x equals x squared plus 1 look like?
A basic parabola with a y-intercept of 1.
Yeah, it's basic parabola, y-intercept of 1, opens up. Does that parabola ever cross through the x-axis?
No.
No, definitely not, right? So all we have to do is integrate from 2 to 5. And that should be our area. So this one is incredibly straightforward. All we want to do is integrate from 2 to 5, our f of x function, x squared plus 1 dx. And what do we get if we integrate x squared plus 1? Integral of x squared is x cubed over 3, and the integral of 1 is x. And so we'll evaluate that from 2 to 5. So 5 cubed, or 125 over 3, plus 5, minus 2 cubed, or 8 over 3, plus 2. And what does that give us?
117 over 3 plus 3.
Which is 126 thirds, which is 42. And since we're talking about area, we'll want to say 42 units squared. Easy enough? So now we'll make it slightly more complicated. So we want to find the area of the regions between f of x equals x squared minus 2x minus 3 and the x-axis from x equals -2 to x equals +3. So this is, again, just a parabola, right? But this parabola is a little bit different. Let's figure out if this parabola has any x-intercepts. How do we figure out if it has x-intercepts?
Factor it and set it equal to 0.
Perfect. So what does it factor to?
X minus 3x plus 1.
X minus 3x plus 1 tells us that it has x-intercepts at x equals 3 and x equals -1. And so we're integrating from -2 to 3 is what we want to do. This parabola opens up, and so it's going to look something like this, isn't it? It's going to cross through at -1, and then cross through at -1, and it's going to cross through at 3. And so we're going to have a nice chunk of it that's below the x-axis, but we're also going to have a piece of it that is above the x-axis. Everybody agree with that?
Yes.
Good. So first off, we will integrate x squared minus 2x minus 3 from -2 to -1. That value should come out to be positive since that region is entirely above the x-axis. So if I integrate that, what does that become? X cubed over 3 minus x squared minus 3x from -2 to -1, which gives us what? -1/3 minus 1 plus 3 minus -8/3 plus, minus 4 plus 6. Everybody agree with the arithmetic there? Hopefully.
Yeah.
All right. And what do we get if we put all that together? -1/3 minus -8/3, that's -1/3 plus 8/3. That should be what? 7/3. -1 plus 3 ought to be 2. And then minus -4 ought to make it 6. And then minus 6 ought to be 0. So this ends up just being, I guess I can just write this over here. This ends up just being 7/3. Yeah? Everybody agree with that? Okay. Now, what about the section between -1 and 3? That is going to come out to be a negative value if I integrate it. So what we have to do is we have to take the opposite of the integral from -1 to 3 of x squared minus 2x minus 3 dx. And conveniently, we've already done the integral. We know it's x cubed over 3 minus x squared minus 3x. Now we just have to evaluate the opposite of that from -1 to 3. So at 3, that should be 3 cubed is 27 over 3 is 9, minus 9, minus 9, minus, and then we already plugged a 1 in before, right? What does that give us? It gives us a -1/3 minus a 1 plus 3. And so what do we get from that? We get the opposite of 9 minus 9 is 0, minus another 9 is -9. And we're going to have -9 plus 1 should be -8. And we're going to have -8 minus 3 ought to be -11. And minus a -1/3, -11 plus 1/3. And so what does that come out to be? That comes out to be -33/3 plus a third is -32/3. And then we make that positive. So we get 32/3 for that section. And so 7/3 plus 32 thirds is 39 thirds, which is
Thirds.
what?
Just
39 thirds, right? Which is 13.
right.
Good or no?
Good.
So nothing new, calculus-wise, mathematically. All we have to do is just use a little bit of algebra to figure out where it crosses through the x-axis, and it requires us to do a little bit more arithmetic. Okay. But important to find the places where it might cross through the x-axis. All right, what about this one? Let's find the area of the regions between f of x equals sine x cosine x from x equals 0 to x equals pi. What should we do first?
Figure out if there are any x-intercepts.
All right, look for x-intercepts. Perfect. So set sine x. If you set sine x cosine x equal to 0, which tells us that either sine x equals 0 or cosine x equals 0, right? Well, on the interval from 0 to pi, when does sine x equal 0? X equals 0 and pi. And when does cosine x equal 0? That's right. Cosine is equal to 0 at pi over 2. So on the interval 0 to pi, we're looking at 0, pi, and pi over 2. So really, the endpoints, it doesn't, those are just places where it touches the x-axis. It's not going to, it does cross through at those, but it doesn't, not on our interval. So we don't need to focus on anything outside of 0 to pi. So we only have one place in between the two where it might cross through the x-axis. And so how can we determine if it actually does cross through at pi over 2?
Plug in pi halves.
Yeah, if we plug in pi over 2, that's just going to give us 0 though, isn't it? So we know it touches the x-axis. How do we determine if it crosses through it? Couldn't we use a sine chart? And say, well, if I plug in something into sine x cosine x that's between 0 and pi over 2, let's say I plugged in pi over 4. What's the sine of pi over 4?
Root 2 over 2.
And the cosine of pi over 4?
Same thing.
Same thing. So if I multiply both those positives together, I know that the value, the y value, is positive between 0 and pi over 2. What about between pi over 2 and pi? Suppose I plug in 3 pi over 4. What's the sine of 3 pi over 4? It's a positive root 2 over 2. And what's the cosine of 3 pi over 4?
Negative root 2 over 2.
Negative root 2 over 2. So we know that the y value between 0 and pi over 2 is positive, and the y value between pi over 2 and pi is negative, which tells us that it definitely crosses through at x equals pi over 2. And in fact, we know it's above the x-axis on the first interval and below the x-axis on the second interval. So we know that what we need to do is we need to integrate from 0 to pi over 2 sine x cosine x. And then we need to find the opposite of, so we'll subtract the integral from pi over 2 to pi sine x cosine. If you want to write them together as, one whole expression. You could also just do each one separately. You could do this first one, then find the opposite of the second one, and then add them together, but this will work too. So how do we find the integral of sine x cosine x?
U
Makes-
substitution.
Yeah, u substitution. What should we let u equal?
Sine.
So du will then be cosine x dx. And so we end up with, let's see here, what's the sine of 0?
0.
And the sine of pi over 2?
1.
1.
And then that just becomes u du. And then we're going to have minus the integral, the sine of pi over 2, like we just said, is 1. What about the sine of pi?
0.
0. Again, u du. Now, before I go through and actually do this integration, what's the rule for flipping the limits of integration?
If you
It's the
units, you flip the sign.
Yep, we flip the sign in front of it and flip the limits. So I could just make this plus another integral from 0 to 1 of u du. And what's an integral from 0 to 1 of u du plus an integral from 0 to 1 of u du? Should be 2 integrals from 0 to 1 of u du, shouldn't it? Or 2 times u squared over 2 from 0 to 1. And what does that give us? 2 times a half minus 0, or 1 unit squared. Good or no?
good.
Any questions on any of that so far? All right. Suppose we have two different functions now, and we want to find the area between the two of them. So not just the area underneath one of them, like the area between the function and the x-axis, but the area between two totally different functions. For example, here is f of x, and here is g of x. Let's just for the ease of this one, let's make it above the x-axis. And I wanted to find the area between A and B, between F and G. So just this area right there. Now, all we have to do is do the integral from A to B of F minus the integral from A to B of G. Right? Because if I do A to B of F, that's going to take care of everything below F, which will include all of the space between G and the x-axis, won't it? And then if I knock off the piece below G, that should just leave me with the piece between the two functions. Good or no?
Good.
Cool. So that's our goal. What if, let's say, what if f of x is up here above the x-axis and g of x is down here below the x-axis? Does anything change?
No, because neither of the functions are crossing the x-axis.
Okay. So you're half right. You're right in the fact that nothing changes, but it doesn't have anything to do with either of them crossing the x-axis. So if I look here from A to B, and I were to do F minus G, well, if I just did F, what would F give me?
The area below A to B.
Right, it would give me this, right? And what would G give me?
Area between the x-axis and G.
It'd give me this area, right? But it would pump out this as a negative value, wouldn't it? Agreed?
Yeah.
Right? And so if I were to do F, the positive, and then minus G, the negative, that should give me all of this space. It should turn this into a positive value and add it to the red value above it. True? Or no?
True.
All right. So now, who was it that said something about it because it doesn't cross through the x-axis?
Me.
You. Okay, cool. Here's one that does. Right, here's F, and here's G. G crosses through the x-axis, right? Still doesn't matter. If I were to do from A to B of F minus G, if we think about the part that's, we'll cut it off here for a second to just think about it. If we just think about this part, F minus G ought to still give me the section between them, shouldn't it? Right? If I do F, that goes all the way to the x-axis, and I subtract G, that goes down to here also and cuts off this section. So it only gives me the part between them. But the same up here is what we just did when one was below, right? It should just give me all of this as positive minus all of this as a negative. So we see hopefully that that doesn't affect it if it crosses through the x-axis when we're looking for the area between two functions. Good or no?
Yeah.
Yeah. Even if F, or let's say even if, let's suppose both of them, I guess I can draw my y-axis up here. Suppose there's F and there's G. Well, the area of F, if I want the area between F and G, that's this section in between, right? But if I do F minus G, I'm getting this small negative here that I then subtract a much larger negative from. And if I do a small negative and then I subtract a large negative, oops, small negative, yeah, small, wrote that really poorly. That's right, a small negative minus a large negative, that comes out to be a positive value, and that's what we want our area to be, is the area between the two of them. Right, so even if they're both below the x-axis, or even if they both cross through the x-axis, then perfect, doesn't matter. Convenient thing about finding the area between two curves is it never ever matters if one of them is above or below the x-axis. All that matters is which function is above the other function. Does that make sense to everybody?
Yeah.
Cool. All right, so let's see if we can do a problem. Let's see if we can find the area between x squared plus 1 and negative x squared minus 1, between 0 and 1. Sound good? What should we do first?
Find if there are x-intercepts.
All right, so, well, let's first just graph them. Yeah, that's a good start. X squared plus 1 looks like this, right? And negative x squared minus 1 looks like this.
Yeah.
True? All right, so one is above the x-axis, the other is below the x-axis, but since we're looking for the area between them, we determined that doesn't matter. The only thing that might matter, which we haven't talked about yet, but we will see, is if the two functions cross through each other at some point. But does that happen here?
No.
No. So all we have to do is take the upper function, which is x squared plus 1, subtract the lower function, negative x squared minus 1, and integrate that from 0 to 1, because that's the interval we're looking for. And so we'll simplify down our integrand first. The integral from 0 to 1 of x squared minus negative x squared is 2x squared. And 1 minus negative 1 ought to be 2. And so we'll integrate this to become 2/3 x cubed plus 2x from 0 to 1. Or 2/3 minus 2. Sorry, plus 2. And then minus 0 minus 0. I don't know why I put a minus 2x there. So 2/3 plus 2 minus the 0 minus 0. And that gives us what? 8/3 units squared. Good or no?
Good.
Perfect. Should we do another one? Let's do another one. Let's find the area between secant squared x and y equals sine x between 0 and pi over 4. So first we'll graph them. What does sine x look like?
A wave.
Yeah. Right, like this. And where is pi over 4? This is pi over 2, right? So pi over 4 is like right here. What about the secant squared function? Where does secant, what's secant of 0?
One.
Secant of 0 is 1. So we're starting here. And as we put in larger values of x between 0 and pi over 2, what happens to secant?
It approaches infinity.
It approaches infinity, right? It continues to increase from x equals 0. So if we're squaring those values, they're also going to increase. So this is going to go up like this towards an asymptote here. And so which function is always above the other function on this interval?
Secant squared.
Secant squared. So we will want to integrate secant squared x minus sine x dx from 0 to pi over 4. And what's the integral of secant squared?
Tangent.
Tangent x. And the integral of negative sine x?
Negative cosine x.
Integral of negative sine, I think should be positive.
Positive.
Yeah. And we'll evaluate that from 0 to pi over 4. What's the tangent of pi over 4?
One.
And the cosine of pi over 4?
Root 2 over 2.
Minus tangent of 0 is 0, and the cosine of 0 is 1. And so what do we end up with? 1 minus the 1 cancels out. We just get root 2 over 2 units squared between secant squared x and sine x between 0 and pi over 4. Good or no? All right, let's do one more here. Let's see if we can find the area of the region enclosed by this parabola and the line y equals negative x. So before we even start to think about this one, what's different about it than the previous problems?
One's linear and one's a parabola.
Okay, well, one's linear and one's a parabola. That's true. Oh, somebody said something. Oh, no, that was from a long time ago. I missed somebody's comment earlier. That's true. But even more so than that, what's different? What did we do here? We found the area between the two functions, between 0 and pi over 4, right? And here we found the area between the two functions, between 0 and 1. And I didn't go there. Here we found the area from 0 to pi. And here we found the area from -2 to 3. And here we're finding the area between the two functions.
It's indefinite.
Yeah, there's no limits of integration given to us. It doesn't say go from 0 to 5 or -2 to 3 or whatever, right? It doesn't give us limits of integration, which means that there must be some finite amount of space in between these. There must be actually some geometric shape enclosed between the two of these. So let's graph it and see what we look at. 2 minus x squared is just this, right? And y equals -x is just this. And so what we're looking at then is the area of the region between them. We want to know what is that area. Well, how do we figure out where to integrate from? We need to figure out where these two functions intersect, don't we?
Yeah.
Yeah. So how do we figure out where two functions intersect?
Set them equal to each other.
So let's do 2 minus x squared equals -x, or x squared minus x minus 2 equals 0. And that should tell us where they intersect, right? Factor this. What is it factor to?
X minus 2x plus 1.
Yep, x minus 2x plus 1. So x is 2 and x is -1. So we know that here is -1, here is +2. We now know exactly what our limits of integration should be. We're going to integrate from -1 to 2. And we have to take the upper function minus the lower function. And we don't need to worry about the fact that part of the region is below the x-axis. That's not a big deal because it's a region between two functions. So which one is the upper function?
Two minus x squared.
Yep. 2 minus x squared and then minus -x dx. Right? So subtract the bottom one. And we could probably just integrate that right now. What's the integral of 2? That's 2x minus x squared ought to be minus x cubed over 3. And then this becomes a plus x, right? So that's plus x squared over 2 from -1 to 2. Good or no?
Good.
All right, and then we just evaluate. So 2 times 2 is 4, minus 8/3 plus 2 minus -2, and then that's a minus a -1/3, so plus 1/3, and then plus 1/2. And do a little bit of arithmetic, and what do we get there? You could get 9/2. Somebody check that, but that's just me trying to quickly do that in my head.
Everybody good? Any questions there? All right. I think let's stop there for now and call that good for today. Sound good?